Hi everyone, my name is Adrienne and I'll be introducing and presenting Chapter 17 on material property correlations. So before we begin, I just wanted to go over what material properties are. So when we're talking today about material correlations, ideally we're sticking with these main properties of materials that we use. So looking at mechanical properties such as strength and stiffness, electrical properties, conductivity, optical properties, whether it's transparent, opaque, physical properties, chemical properties, the magnetic properties of materials, and then finally also the thermal properties. So I'm looking at the melting point. So why is this important for engineers? Engineers, obviously, when we think about their use of materials, they're involved in a lot of the creation of various buildings, or other structures that are all around the world. So ideally what they need to do is they need to be aware of the type of material that they're using to create such a structure. Specifically keeping an idea in mind out for weather as well, natural disasters. So you figure places where hurricanes are more likely, obviously you want to look for a stronger material that's going to withstand some heavy wind forces. Same thing when you look at places where earthquakes are more likely and tornadoes are more likely. So ideally, what happens with material correlations is engineers will be looking into using certain materials based on the property that they're looking to have. And there are times where the needed property is not available. So what do they do then? So this is where property correlations comes into play. And I will say this was very difficult to understand through the text, so bear with me as I try to explain it to the best of my ability. So basically, property correlations are used when a material has an unknown property value. So how that material then compares with other like materials and their property value ideally gives a starting point for where it would fall in a correlation chart of whether it be a good material to use or not. This blends very well with chapters 6 and 8, which talk about estimating and data checking, and also the ratios. So correlations are ultimately found when looking at atomic level bonding of the elements. So basically the bonding process happens when two elements become bonded. Basically the closer they move together, there's a point where there's an attractive force and repulsive force. And when those are kind of equal and kind of equal out, that's when the elements are bonded. So then, ideally, the force curves create what's called a net potential energy curve. And this is where we see the correlations really come about. Ideally, they said the depth of the well of this curve is what it would take to separate that bond. So for some of the properties, the deeper the well, the stronger that material is. So the stronger the melting point or higher the melting point would be, or stronger the material would be when you look at its strength. So ideally, correlations can happen between the following materials based on the net potential curve. So the strength of the material on the melting point is a correlation that can be looked at. Elasticity and melting point is another one. Elasticity and strength. Hardness and strength, and then density and specific heat. So those are just a few of the correlations that they discussed in the book. So this was taken from the book, page 138, and you can see it shows the strength of a material versus the melting point. So for the most part, ideally it does kind of follow along that idea of the stronger the material, the higher the melting point. But there are a few areas in which the material has a higher melting point, but a much lower strength. So this is important for engineers when looking to determine what material they should use based on what they know of what they need it for. And, obviously, like I said, weather has a huge impact when you're looking at building structures. So I also represented the table. I know we kind of already looked at it when we were kind of discussing this chapter overall. But this just gives you another good idea of, and it just kind of gives you the numbers versus the actual chart. So you're able to see on page 138, strength versus melting point of some common elements. And then on page 139, again, we're looking at different metals or alloys and their thermal conductivity versus electrical conductivity. So the big question is, how do we implement this into the classroom? How do we take this knowledge? And like we discussed earlier, this was something that I struggled understanding how I would bring this down to a primary grade level. But you guys came up with some great ideas, obviously talking about electrical safety and just having kids understand the basic knowledge of, what to do if they see an electrical wire, the casing around it has been shredded off. Is that a danger? Is that not? But then also kind of doing some fun experiments. I know there was the concept of the solar oven, which is always a great thing for kids who doesn't want to have a s'more. So just looking at the different materials it would take to have them test out to ultimately see what would melt the marshmallow and chocolate the fastest. But then I also found some that would be kind of maybe for the higher grades. One is looking at kind of roof materials and identifying kind of the waterproof, which material would be the most waterproof. But also you have to think about the strength of it. And obviously, depending on the area in which you're putting it in, it should withstand, to some extent, wind. So there has to be a strength to it as well. But then the other one I found, which was kind of unique, was a heat loss project. And I find this really unique because I think it provides a lot of kids with a real world application to it. So obviously solar ovens, s'mores, yes, we're talking about solar energy, but there's not much of a real application for students to kind of connect with. I know for my students, they obviously live in an urban setting, high poverty area as well. So I can imagine that some of my students do struggle with not having a home as warm as preferred or as most people might keep it at, just due to lack of funds and lack of being in a building that has, updated material that would help keep heat in and keep the cold out. Working in an apartment community, I know very well just from people coming in that people coming in from private landlords sometimes or from older buildings always complain that the windows don't keep the heat in. So I thought this was a great project to kind of connect with a real world problem that a lot of people face of how to maintain a heat within their home, and kind of looking at the different materials in which homes could be built out of that would be more efficient in keeping the heat inside, or for summertime, keeping the heat outside. So I thought that was another kind of great project. Obviously, that would be more for an older group of students versus a primary. But I know even in my primary classroom, we do lessons on natural versus human-made materials. And I think that's a great way to kind of segment some of this knowledge in. Obviously, not to the extent of them identifying correlations and looking at the numbers and everything, but more so just looking at different materials and identifying, would this work for strength and melting point? So I think that'd be a good one because primary kids can understand strength of a material, and for the most part they can understand melting point as well. So I think looking at that correlation and what material would work best in certain instances would also be a great way to segment some of this higher thinking into their lessons that we do with them already. So I'm sure you guys have a lot of other ideas too, some that you've already done or something you want to do. So I hope to hear about some other ideas. And if you have any questions, let me know.